Shrotikanta Guha Foundation is a charitable society which was established in September 1991 in memory of Shrotikanta Guha, who expired in January that year. Since the names of Shrotikanta Guha and wife Pritilata Guha, the first secretary of the foundation, are indissolubly linked with South Point as its founder and its associate founder, the first members of the foundation decided that education should be the main sphere in the foundation's activities. Currently, Shrotikanta Guha Foundation owns 3 schools in West Bengal: Garden High School, Kolkata, affiliated to Council for the Indian School Certificate Examination; Garden High International School, Kolkata, which follows the IGCSE curriculum; and Garden High School, ISER, Kolkata, affiliated to Central Board of Secondary Education. By setting up the Shrotikanta Guha Center for Culture and Learning, SKGCCL as it is known as, the foundation aims to nurture young talents in the fields of art and culture. Shrotikanta Guha Center for Culture and Learning conducts a variety of short-term and long-term programs in communicative English, foreign languages, music, dance, drawing, painting, photography, short filmmaking, etc. SKGCCL, in an effort to supplement the formal curriculum offered by educational institutions, organizes cultural programs, webinars, seminars, and workshops, both online and offline, for various subjects and topics on a regular basis to ensure the overall development of young learners. Such programs are open to all educational institutions with specific target age groups for each program. This morning, it is my pleasure to introduce our special guest, Dr. Subhamoy Maitra. Dr. Subhamoy Maitra is a professor at Indian Statistical Institute, Kolkata. He is the head of Department of the Applied Statistics Unit in ISI, Kolkata. Ranked 5th in higher secondary examination, Professor Maitra graduated from Jadavpur University in Electronics and Telecommunications. He then completed his M.Tech in Computer Science and PhD from Indian Statistical Institute. His primary research interest is in Boolean Functions and Cryptology. We are really thankful to Dr. Maitra for taking the time out of his busy schedule to be here with us. May I request Dr. Maitra to please accept the token of appreciation. If you could just come here. Thank you, sir. Over to Dr. Maitra.
Thank you, madam. And thank you, Amita Babu, for kindly inviting me. And thank you all. I think more than 150 or something like that students, and multiplied by 1 hour. So I got a huge amount of fun today that each of you are listening to me for 1 hour each. So I would try to describe a little bit of history, some computer science related mathematics that I'll try to write on the board. Possibly most of you won't be able to see. So I'll try to explain. And my English would be pathetic, much worse than you. That you have to accept. That is, if I would have talked in Bengali, it would have been much better actually. But okay. So because science has no language, as you all know, we just need some symbols. So first let me make a few sentences about science. Science is a subject that accepts incompleteness and uncertainty. Like in society or politics, what we do whenever we tell something, we tell that I'm correct. Any political party, if you see, they will tell I'm correct. That cannot happen in science because science goes through logic. So when we have Dalton's theory, after a few years, we know that Avogadro told something which might be more correct or correct, those kinds of things. We have paradoxes. In a piece of paper, if we write on one side that what is written in the other side is true, and in that side if I write what is written in the other side is false, then you would immediately understand the paradoxical nature of those statements. So just let us start with a little bit of definition of uncertainty and incompleteness, then we would come to computer science, because there is some famous theory of Gödel which talks about incompleteness. Uncertainty is something that what is coming we really do not know. We try to guess what might come. Consider cyclone. Nowadays we can actually watch the movement of the cyclone. So more or less we are certain when it will landfall and all these things. On the other hand, if we consider about earthquakes, really we do not have much knowledge about it. So there is still uncertainty, and science accepts that I do not know that when it will happen. So this is called the uncertainty part. A big part of science is to understand what might happen in the future, and if it matches, that is good. If it doesn't match, nothing to do. We start to learn again. That is the basic theory of artificial intelligence or machine learning, which actually comes from these kinds of mathematics. Shannon's theory and all those things in 1950s, 60s, that was developed. The other part is incompleteness. Incompleteness means we know that certain things might be true, but we do not know how to write the proofs. So if some of you will may later learn mathematics or computer science, then you would learn how to write proofs. So like consider the sum of internal angles of a triangle is 180 degree. So you have some premises that comes from Euclidean geometry. If you draw the triangle on a football, then the sum might not be 180 degree, right? But you have to work on the plane. So there are certain things that we need to define. Consider the famous Goldbach's conjecture, that any even number can be written as two prime numbers. So now if I ask you to prove that any even number can be written as the sum of two odd numbers, you can always prove that, right? Most of you will be able to prove that. But when we tell that no, you have to prove that any even number can be written as the sum of two prime numbers, then the proof is still incomplete. From 1600, lot of mathematicians are working, like Fermat's theorem was proved around 10-12 years later. You can see a BBC documentary, Andrew Wells proved it. So similarly, this problem is still unsolved. Maybe some of you might solve it and get the Millennium Prize after a few years. So this is called incompleteness. We know that we could not prove it yet. So what is the difference between society and politics? You will never find a political leader who will tell what I am doing. I really do not know what will happen. I am trying to do these things, and I am failing in these points, I am passing in these points. So like us, the third world countries, the development of social sciences is generally away from mathematics and statistics, which is not true in first world countries like Western Europe or USA, where we consider their academic involvement is little better than us. There we always try to prove things with mathematics, with science. So there is a trend in the world now as science is developing, that when we are talking about philosophy, when we are talking about politics, when we are talking about society, we try to quantify things, and computational science, when we talk about computation, is related to this thing. So let me try to start the presentation. So when we talk about people in the history of computing, we need to talk about three people. And again, this is my interpretation, so it might not be correct. There are many other people in the world who contributed in this domain. Since I work in these three areas, I thought that I take these three persons' name and form a triangle of the development of computer science. So I would mostly talk about Boole, Turing, and Feynman. Science to technology, this is an important evolution. We have to understand very clearly. What we prove in science and when we try to transfer it to technology, this takes a lot of time. And here actually society, philosophy and all these issues come. When I am designing an aeroplane, there is a lot of mathematics, but related to that we have to understand several social, political issues. When I am understanding nuclear science, from that I might use it as a power station to provide electricity kind of thing to several villages, or I can use the nuclear science to prepare an atom bomb and drop somewhere. So here society comes. So you really cannot separate out society or politics from science. And development of science, sometimes it is really very fast due to certain political and social decision, such as we have the example of First and Second World War. The kind of development in technology, I am having goosebumps, the kind of development we had in technology during those two wars, that is generally not discussed much, but starting from cryptology, starting from aircrafts, any kind of communication, huge amount of development happened. 1914 to 18 is the First World War, and after that 1939 to 45 possibly the Second World War. And in between that period, there were a lot of mathematicians, physicists, chemists, results related to medical domain, physicians, so huge amount of improvement. So this is what is very important, and that is why the question of how science evolves, that is not only related to solving some mathematical or physical problems. And then Boole, Turing and Feynman, I will talk about them, and after that you decide whether you would consider them important or we should consider other people also. Science is developed, science and technology is developed by many people. The most important thing that you have learned a little bit is Boolean algebra. Already some of you might have learned how technology developed. If I can tell, I think you already from class 8 or 9 you have started learning Java, right? Some of you are writing programs in Java. And I remember when I joined some software company in 1994, that time actually the language was getting developed. We had to download lot of things, and I have then already completed Master of Computer Science. Then I was thinking, okay, I'm learning something huge. And nowadays in the classes you are writing programs, right? You are writing so java.packages, AWT packages, advanced window toolkits, right? You are writing classes, right? You are creating objects. Some of you might know the difference between small int and capital int, gr, all those things now you understand. So find out the difference. At the age of 24, 25, I was learning something, and you are learning that at the age of 14 or 15. So this is how science is developing. At our time, most of the time we didn't learn determinant or matrices in school level. We learned only in colleges. Now, in many syllabus, we find that class 11, possibly determinant, matrices, those are being covered. So that is why science is evolving. Turing machine is the next part, where we provide the mathematical model of a computer, and then we would talk about Feynman. So all three characters are very interesting. So while we will talk about their contribution, and the characters are such that you might not be enough mature to understand them, but you remember their names, and maybe later when you grow a little older, then you think about these people, how they contributed to the society, what are the crises of these people, being such a big person. So it's almost something like our poet Jibanananda Das. So during his lifetime, really he was not understood properly. Even today when we learn the Bengali words from his poems, we really think how he could write this. When we talk about Rabindranath, he was more celebrated, but even if you read Rabindranath, how could a person write all those things? So these three persons are almost like that. So one bracket is missing, I have noted that earlier. So industrial revolution, why I come to these things? Because this is a transition to new manufacturing processes in Great Britain, continental Europe and United States, 1760 to 1820. So the transition, what the transition included? Hand production methods to machines, new chemical manufacturing, iron production processes, increased use of steam and water power, development of machine tools, rise of mechanized factory system, and that actually developed capital, in Bengali Punji. So that turned the world, and not only in terms of technological development, also the society started to change. We didn't have the idea of capital in that situation. And what is the most important part? The most important part is muscle power was going to be replaced by the power from the machine. Why it was required? Two things. If a person got unwell or a person die, I really cannot take one part of the person to put that thing in another person. Now, medical science developed a lot. It happens sometimes that one person is dying, we can use the heart or some part of the body in the other person, but generally that is economically not viable. So if I have lots of machines, if two machines are bad, I can take one part of one machine, another part of another machine, I can connect them, one machine will at least run. So reusability of machine. Next thing is human power, there is some limit. Even if it is not human, you are using horses or something else to pull something, there is a limit to the power, and once you cross the limit, you try to arrange more than one entities to take together to increase the power. That was the idea. And now, when it happens, maybe for horses you can do these things, you can run a sledge by 20 dogs, but when you work with human beings, they will protest. They won't listen to you. That is natural. When we are in a class, we do not always listen to our teacher, right? He or she talks and we play tic-tac-toe in the backside, or maybe if I have a mobile, if I can open it, if I am not caught, then I look at something. So this is very natural human psychology, right? So this human psychology, what it forced, that people started protesting, people tried not to work, and then we understood that, okay, then if we have machine that will listen to us. So industrial revolution was the part where we could replace the muscle power, and you see that it was something like 1760, 1820, 1800, we have more than 200 years, 1820 if you consider it is 2022. Still we have lot of new mechanical devices coming, which are helping us in building bridges, houses, and all these things. So when we have these kinds of, earlier there were some developments, scientific developments, but this kind of industrial revolution in this short period of time was really very interesting. Now you talk about the revolution of computation. Now comes brain. If you are asked to multiply one 20-digit integer by another 20-digit integer, it would take some time, right? It will take much longer time than you multiply a 3-digit integer with a 3-digit integer. So when you are doing these kinds of things, one part is it's sometimes quite boring, sometimes the problem is you cannot do it very fast, and sometimes the problem is there might be errors. So as in the time of industrial revolution, around 1910, 1920, as I told, First World War was almost coming, people understood that if we can manage computations in this manner, that would be very interesting. So that was one of the ideas, that can we manage this kind of thing. So Boole, 1815 to 1864, and I always get confused with the century. When you have 18 something, it is plus 1 century, right? So it is 21st century possibly. So pointed out that most of the mathematics can be handled by binary. So I thought that I will write on the board to show you decimal to binary conversion that we would see towards the end. So let us be less technical now. So the main issue that I want to tell you, what is the power of this number system? The power of this number system is we can write the numbers in a very concise manner. It will take a long time to move through 0, 1, 2, 3 up to 999. You just go on counting, it will take at least 3-4 minutes if you count very fast also, 0 to 999. But how can you write down 999? So when you will learn logarithm, I'm not sure whether you have learned logarithm already, you have learned. So you see, logarithm of any value is very small. And similarly, logarithm of any value base 10 is very small, and that is why actually we have this representation. So this representation, this number theory kind of thing, that when we can write in a concise manner, and again, don't give credit to some Ved, some Aryabhatta, some West Asian countries people. So this is not done by any religious leader. This was done by people, done by mathematicians, done by people who thought about these things. He might have some kind of religious thinking, there is nothing wrong in it, but it have not come from God. Right, so people worked on scientific manner and they understood I can represent something in a very small space which is actually very large. So value of a number and representation of a number is related by logarithm or exponential. You are representing with 3 digits, it is 10 to the power 3, 1000. You can represent 1000 by 3 digits. You have 1000, you take log, you can represent it by 3 digits. And all the computation that we can do is only due to this thing. Very important, that number theory that tells us, that teaches us how to write numbers very easily. If we didn't have this thing, then you had to add 5 plus 7 as, after 5 you have to count 6, 7, 8, 9, 10, 11, 12. You do not do that. You just add digit by digit. So 12 plus 27, you first add the first digit and then add the next digit. Might be there is a carry. So this tells you that not only representation but all the operations you can do very fast, and that gives us the basic idea of computation. We are stuck somewhere, we know where we are stuck. We can multiply very fast, but if you take two large primes and if you multiply them, because we can multiply very fast, if you give it to somebody and ask him or her that please give me the factors, it will take a long time. You can make a test for this. So you multiply 23 into 31, it will just take very little time, but if you give the product to somebody, it will take some time for him or her to factorize it. So this is the famous factorization problem. When we will talk about quantum computer, we will tell that this factorization problem cannot be solved efficiently in classical computer, and based on which all the banks of the world are secured. And suddenly Peter Short told in 1992-93 that if we have a quantum computer, then we can do this thing also very fast, and another revolution started, which is the revolution of quantum computation. So I am actually planning to talk about this revolution. So Boole talked about these binary things. So why binary? Binary means earlier you were using 0 to 9, those digits. Now it can be easily proved that everything you can write with zeros and ones. Not very hard. So you have to learn little bit of function and relation, and then you can some very basic mechanism where you can write any integer using 0 to 9 by 0 and 1 only. So why 0 and 1? 0 and 1 because if you know about little bit of current and voltage, you will see that when I have a battery, I have plus 1.5 volt and 0 volt. Similarly, if I have a larger battery, I might have plus 5 volt and 0 volt. In the same battery, generally I do not have 0 volt, 1 volt, 2 volt, 3 volt, 4 volt, 5 volt. So generally we have only 2 points. One point is 5 volt or 1.5 volt, another point is 0. So now, if I want to prepare circuits, what I will do? I will consider the positive voltage as 1 and the ground level as 0. So I can now build any circuit with 5 volt and 0 volt. So that is why binary is very important in implementing any kind of classical computer. And what Boole did, you see, 1815 to 1864. So that is what we sometimes tell generally in our national level or in the world also for theoretical computer science or mathematics, there is very little fund. We tell what they are doing. Well, their things are not being used in industry. And generally when we talk about grants, we really do not get high grants for a project related to mathematics. This is very natural. If you build some small robot with 1 or 2 processors, people would be very happy to see. But if you solve a mathematical problem, nobody would show that much of interest. This is natural. But the point is, whenever you do something in maths, how it can be used is mostly understood the top things after 100 or 200 years. So what Boole proposed, based on that, almost 100 years later, classical computer model was visualized by Alan Turing, von Neumann and several other researchers. The model of computers, I should have, that is why I told that, why I took the name of Turing, because more colorful character, you can replace Turing by Neumann also. Both these people are very good in mathematics, physics, computing and all these things. So the model that Turing or Neumann studied, that was limited by classical physics, or we can talk about general electricity, Newtonian mechanics, those kinds of things. So that is termed as classical computers. What is the model of classical computer? To speak very simply, I have a processor that can compute something, the circuits that I told, and I have some memory, which is something like an exercise book. So you want to add, say, 12 plus 19. In the exercise book, 12 and 19 are written. Those are memory. You bring them to the processor and then you add them. You find out the result and then you push the result, write the result again on the exercise book. So this is the memory and this is the processor. If you can just do these two things, then more or less, believe me, you can do whatever is done in any classical computer in the world. It will take more time because you are doing by hand, so it would be slow. These things are actually done, and that is the von Neumann model of architecture, which was in some other terms, it was given by Turing. What was the model of Turing? You have possibly not seen, but if you have cassette recorder kind of thing, where you have sometimes music, you can listen music from that. So there is a head and there is a tape. So on the tape, certain data is written and the head is reading from that and computing something. So that model is also equivalent to this. So these are the parts of theoretical computer science or computation. You might read a little bit of this part if you take computer science, possibly in 10+2 courses you have computer science. I'm not very sure, might be 8, 9, these things can be covered. Till the end of 19th century, most scientists believe that Newtonian laws governing the motion of material bodies and the Maxwell's theory of electromagnetism are the fundamental areas of physics, but that changed. So quantum computation, it started 1920, 1910, that time. 60s we got some idea of quantum computation, quantum simulation, and basic model was presented by Feynman in 81, considered to be the seminal idea of a universal quantum simulator. So whatever computer you are seeing here, mobile phone, everything is a classical computer. And now we are expecting quantum computation. Feynman proposed the initial idea and most of the developments are happening now. We are involved in that research. If actually those things can be delivered to you commercially, then the world will change. I will try to talk a little bit about that. Okay, next. So how to compare these two revolutions? One revolution is revolution of muscle, power to be replaced by machines, and the other revolution is replacement of the power of brain by machines. So these two would have completely different kind of characterization. There would be some similarity also. Society, if you compare two things, you can always find out some similarity, you will always find out some differences. So muscle, brain and their limitation, that produced these two revolutions. In history we do not write what I would say, the intellectual revolution or computational revolution, we do not have any history for that. Might be it would be written after some years. So one, as I told, hard to force people to work. People will revolt if they have to work continuously. Human parts cannot be assembled to develop another human. Some medical science is there. We have May Day, 1886, big history related to that. Social and political scientists at that time were top grade intellectuals. So just give a search of letters between Marx and Engels on advanced calculus. So the people you are watching every day on television, that is not the scenario of politics around the world. If you talk about Mussolini, who was generally considered to be a bad person, if you read through his life, you will find up to the age of 32 what kind of contribution he has made towards social science. And then there was some kind of development and those things happens. But if you get into the work of the people who has contributed very seriously in social sciences and politics, they had very strong idea in mathematics at that point of time. This is not happening. There is little difference if you talk about Singapore and India. You just go and search the web page of the political leaders in Singapore. You will find most of them are top graduates from Oxford or Cambridge or some other universities. And that is how a system develops. So there are what I would say, there are debates between different kinds of policies, but when you try to implement something, you really cannot bypass science and technology. Okay. So now, little bit on George Boole. Let me check the time. Almost half an hour. So you have to take the pen for only 30 minutes more. So English mathematician, philosopher and logician. So see why I am talking about these things. He was a philosopher also, not only mathematician. Worked in fields of differential equation and algebraic logic when he worked in the domain of mathematics. Best known as the author of the law of thoughts. So if you look at the name law of thoughts, you will surely think it is only philosophy. But that gives the idea which contain Boolean algebra. That is why I have given the example of Marx and Engels, that it's not only Das Kapital, it is also development of calculus. So there is a famous prize, George Boole International Prize now. We give this prize every year from Norway. So little bit of a YouTube screen I have taken because without telling some 30-40 seconds would be useful. So if we can run the file.
His work in symbolic algebra is the root of today's technology.
He's discovering and inventing new languages that can describe things in a mathematical way.
George Boole developed the foundation of computer logic.
The 1 for on and the 0 for off.
And yet, his contributions have been historically overlooked.
No George Boole, no Google, no Amazon.
The story of how a poor Irishman changed the world on the genius of George Boole.
So this is the trailer. You can watch it later at your home. And so for all the three persons, I'll talk about their death. This is a very interesting area for all big people, how they died. Because the birth is generally not controlled, but the death could be controlled. Now, you have already read the story. So whenever I have studied this, I had one question that we had umbrella at that time. So why didn't he use it? And why his wife, if it is true, thought that if you put him in a wet blanket, then it would solve the problem. So, philosopher of or mathematician of such a high stature died in this manner. And at what age? You can see that he died possibly less than 60 or less than 50 years, 40 something, right? So, this is very interesting. So, these are the places where we might need to go through that, what kind of understanding was there at that point of time, or might be, it could happen that really Boole was not famous at that point of time. Nobody took care of him that seriously. Okay, next. So these I thought I will go for board work, but we cannot do, we have less time. So these are the things: Boolean logic, Boolean functions, implementation of classical circuits, combinational logic, sequential logic, and towards classical computational models. These are the area that Boole has actually contributed. We could not understand at that point of time. My research area is actually Boolean functions, and now we can see a complete computer as a Boolean function with large number of inputs and outputs. We have to design such circuits, we have to understand those circuits. We have combinational and sequential logic. Sequential logic gives the idea of memory that we have in the computer. The combinational logic gives the idea of CPU, the central processing unit. So everything was somehow, I'm not telling he could thought about those things, but he developed the things that we had to use. Without the Boole's contribution, all the classical computers that we are seeing now, the existence wouldn't have been there. Okay. Next. So now, Alan Matheson Turing. So, English mathematician, computer scientist, logician, cryptanalyst, philosopher, and theoretical biologist. So, theoretical computer science. What is theoretical computer science? I have a computer here, I can see, I have a mobile phone, I can see. So what is theoretical computer science? Theoretical computer science is something like Newton's laws of motions, 3 laws that we can always write, we can understand, and then based on those things, we have lot of products that are using those things. So it is formalization of concepts of algorithm and computation with Turing machine, which can be considered as a model of general purpose computer. So if you have any classical computer, you can just represent it in this model, and then you can do some mathematical calculation and you can tell how much it can work. So I would like to tell a little bit about Gödel's incompleteness kind of idea. You can write programs, right? So consider a program that takes as an input another program, like .java file. So you write a .java, something a.java. What a.java takes? A.java takes as its input another program b.java. You can put it in a file, and the input to the program's b.java. Okay. So now a.java takes 2 inputs. One is another text file, which is b.java, and inputs to b.java. Now I have to tell, a.java had to tell that b.java program with that input, will it terminate with that input or it will never terminate? This whole scenario becomes very confusing when in the program a.java, you put a.java as input and another input to that. So these kinds of scenarios, you really cannot tell what will happen. And what is the problem? In software engineering, there is a big part called testing. What we try today, writing programs are becoming very easy, but testing the programs for computational issues, what are the troubles, like credit card. Some credit card transaction fails. It fails for some problem in the program, and when we try to solve these things, all the problems cannot be solved mathematically or automatically. We need human intervention, so there are some limitations of computations also. So this is very important. Science knows the limitation of what it is developing. So there is a very famous award, Turing Award, which is given to the best person in computation every year. So again, let us hope that some of you would get that. And a small trailer of Imitation Game, a famous movie, you have possibly seen, some of you.
This war, we're not winning it. If you speak a word of what I'm about to show you, you will be executed for high treason.
It's beautiful. It's the greatest encryption device in history, and the Germans use it for all communications.
Everyone thinks Enigma is unbreakable.
Let me try, and we'll know for sure.
Mr. Turing, do you know how many died because of it?
I don't.
3. While we've been having this conversation.
Gentlemen, meet Mr. Turing. We to work together then. I'm afraid these men would only slow me down.
Popular at school, were you?
We're short on staff.
We get more staff then. You have 6 minutes to complete the task.
Is it even possible?
No, it takes me 8. 5 minutes and 34 seconds.
You said to do it in under 6. What is it that we're really doing?
We're going to break an unbreakable Nazi code and win the war.
Oh.
You know, to pull off this irascible genius routine, one actually has to be a genius.
I'm designing a machine that will allow us to break every message, every day, instantly.
You're going to need all the help you can get, and they are not going to help you if they do not like you.
Have you decrypted a single German message?
You will never understand the importance of what I am creating here!
Our patience has expired.
No!
If you fire Helen, well then you'll have to fire me.
Me too. And me.
You better bloody work.
Helen, you do not have to do this alone.
What are you doing? What's going on?
The Navy thinks that one of us is a Soviet spy.
You've got more secrets than the best of them.
What if I don't fancy her in that way?
Can't tell anyone, Helen. It's illegal.
I'm just a mathematician.
Sometimes it is the people who no one imagines anything of who do the things that no one can imagine.
So the So clapping for whom? Okay, so this is one of the famous movie and must watch. I won't tell that you are enough mature to watch this movie now, but I really don't know, you might. So yes, so let me come back. Let me come back to that. Yes, so now we have to read this. The death of Alan Matheson Turing. Same as if you have read the poems of Shukanto Bhattacharya, who died at the age of 21 years. So, and you should read the life of Galois. He died the day before the duel where he died. He was injured and died at the age of 18 possibly. He worked on Galois field, and famous result of Galois field that you might learn if you are studying mathematics. So there are people, and this is a subject to read actually. This should be part of the history of mankind that we generally do not read. We only read about the big politicians, the kings. Even after Tagore's poem, রাজছত্র ভেঙে পড়ে রণডঙ্কা শব্দ নাহি তোলে জয়স্তম্ভ মূঢ় সম অর্থ তার ভোলে. But you know more names of politicians, right, than Alan Matheson Turing. Same for me. So, okay, next. So, these are the contributions of Turing. Computational models, Turing machine, von Neumann architecture is related to us. So, we should celebrate von Neumann also, while we are celebrating the life of Turing. Contribution to AI, the imitation game. The name of the movie is actually the name of a research paper. Give a search, you will understand that when we are telling a computer has artificial intelligence, when a computer can imitate somebody. Okay. So say during the COVID time, we are having classes, online classes, we are in bad mood, suddenly network is stopped and some student is telling, Master Mashai, apni to chhobi hoye gechen. Right? It was stuck, the frame is stuck. That happened to me. Yes, some student told. So, this is how can a computer have wit? Can a computer have wit? And why we are talking so much about computers? For some reason we have passed through the COVID time and we faced how computer and communication technology helped us. It is very unfortunate that we could not spread it among all the children of the world, but many of us, we got the facility and we used that. So this is the power of computation and communication. This is a revolution that has saved us from this COVID period. And obviously cryptanalysis, people tell that it changed the outcome of Second World War. It would have been different. Some people, you might read the history that some British army, German told they didn't kill them, they just left them, but that might not be the reason. The reason might be whatever the Germans were doing in this front, the Western front, the Eastern front was Russia, and the Western front, that was actually a lot of things could have been, I'm really not sure about the whole history, but might be the contribution of Alan Mathis and Turing. Okay, next slide. And then Rick Feynman. Most of you must be knowing his name. So, American theoretical physicist, known for his work in quantum mechanics, quantum electrodynamics, got a Nobel in 1965. Superfluidity, particle physics, worked on many things. So I'll come to the YouTube video a little later. So one of the best known scientists in the world, he assisted the development of the atomic bomb during World War II. What was the name of the project? Manhattan Project. Became known to a wide public in the 1980s as a member of the Rogers Commission, which investigated the Space Shuttle Challenger that was destroyed, its investigation. There are a lot of documents on that investigation. Very interesting, with political implication also. US politics changed a little bit on that. Autobiographical books, you must start reading. Even today itself, you should buy or download the PDF. Surely you are joking, Mr. Feynman. A must read for all the students. And what do you care what other people think? You might read a few days later. 3-volume, very famous publication in undergraduate text, The Lectures of Feynman. Those who study physics at undergraduate level, I'm absolutely sure some of you will study physics. You have to read those 3 books. Yellow books, very interesting. We also bought those books while we were students. Couldn't read more than a few chapters, but you would surely read that. Feynman has been credited with pioneering the field of quantum computing. So next slide. This death is much simpler, at least. So he declined to undergo the dialysis and all those things. He was quite old, but his last words were very interesting. I would hate to die twice. It's so boring. Right. Okay. So he has a lot of political thing. See, as a US person, you know that the Cold War kind of scenario, the autocratic communist government of Russia, he tried to visit some parts, like you see in Chinese Taipei nowadays. So a government, whether it is left or right, it can always be autocratic. And that also a part of, like North Korea, you will find people are not getting food, but they are developing many missiles. So that is also another part of science, that development. So in the next page. So this is more or less, I'll come to Feynman's interview just after this and finish the talk. So the main contribution is idea of a quantum simulator, basics of quantum computing, factorization problem, source algorithm, and cryptanalytic implications on classical public key models. If I have a classical quantum computer now today on this table, all the banks will be destroyed immediately. All the communications, the cards and whatever you are using, we cannot break them because we cannot factorize the product of 2 large primes. Once we have this machine, it would be factorized. So everything. So huge amount of money is being pushed into the domain of quantum computing. Some of you who would read computer science or physics, there is a very high possibility that when you will become an engineer or scientist, you would work on quantum computation. This is going to be the area. Already trillions of dollars are being invested, and it is just developing. It is almost like 1910, 20, 30 when computers were being developed, classical computers. We got that in 1980, 90 we got computers. For quantum computers, it is something like that. The development started in 80s, 90s, 2000, and we are now developing, and there is a good hope that we would be able to get a commercial quantum computer by 2040 or that time. Next slide. Importance of quantum computing. See, the Nobel Prize is also some part of politics, right? It rejuvenates the market sometime. You would find in last few years, in 2012, 2016, and this year, 2022. So we have 3 Nobel Prizes, and the last one, entangled state, is a very interesting property of quantum particles, that if you have 2 particles, a 2-qubit state, quantum bit is known as qubit. It is not 0 and 1, but it is superposition of 0 and 1, alpha 0 plus beta 1, where alpha and beta are complex numbers, such that mod alpha square plus mod beta square equal to 1. Oh, let us forget that for the time being. So if there are 2 particles and one particle is in Garden High and another particle is in Indian Statistical Institute, if you change or do something on one particle, the effect would be understood on the other particle. And this entanglement has huge contribution in terms of secure quantum communication. So if all these banks, when they will crash due to this attack, might be the networks with quantum entanglement will help us, will protect us, we will devise new algorithms to solve these problems. Next. So the talk is complete. I would have a small interview of Feynman, and that would be the last thing.
Was it worth the Nobel Prize?
Please listen to the interviews very carefully.
Answer. I don't know anything about the Nobel Prize. I don't understand what it's all about or what's worth what. And if the people in the Swedish Academy decide that X, Y, or Z wins the Nobel Prize, then so be it. I won't have anything to do with the Nobel Prize. It's a pain in the... I don't like honors. I appreciate it for the work that I did and for people who appreciate it, and I notice that other physicists use my work. I don't need anything else. I don't think there's any sense to anything else. I don't see that it makes any point that someone in the Swedish Academy decides that this work is noble enough to receive a prize. I've already got the prize. The prize is the pleasure of finding the thing out, the kick in the discovery, the observation other people use it. Those are the real things. The honors are unreal to me. I don't believe in honors. It bothers me. Honors bothers me. Honors as epaulets. Honors as uniforms. My papa brought me up this way. I can't stand it. It hurts me. When I was in high school, one of the first honors I got was to be a member of the Arista, which is a group of kids who got good grades. And everybody wanted to be a member of the Arista. And when I got into the Arista, I discovered that what they did in their meetings was to sit around and to discuss who else was worthy to join this wonderful group that we are. Okay, so we sat around trying to decide who it was who would get to be allowed into this Arista. This kind of thing bothers me psychologically for one or another reason. I don't understand myself. Honors, and from that day to this, always bothered me. I had trouble with when I became a member of the National Academy of Science, and I had ultimately to resign because there was another organization, most of whose time was spent in choosing who was illustrious enough to be allowed to join us in our organization, including such questions as we physicists have to stick together because there's a very good chemist that they're trying to get in and we haven't got enough room for so. What's the matter with chemists? The whole thing was rotten because the purpose was mostly to decide who could have this honor. Okay, I don't like honors.
So since I'm getting old, I generally try to be very careful not to give any GAN to the students. I like to be like the students only. So the point is, the kind of academic honors is completely controlled by a group of mafias in academics. Like in politics, you have group of mafias. So when you look at the honors in different places, just don't look at the person by the honors he or she got. Judge the person by the work he or she has done. Thank you very much.
Any question you can ask, sir?
And I won't be able to answer mostly, but there is always a question and answer session, right? So I don't think, after my talks, I generally don't receive many questions because I cannot generate that inquisitiveness. So is there any? So one thing Sir told me to little bit to talk about little bit of the banking system and what happens here. So there is an algorithm developed by Rivest, Shamir and Adleman, which is known as RSA, Public Key Crypto Systems. The public key crypto system is developed in such a manner so that the two keys are different. So consider an almirah, you have two same keys. Somebody can open it, somebody can close it if two persons have that thing. But this thing is little different, where you have a post box, where one key is from the place you are putting the letter. Once you put the letter, only the person who received that, he or she can open it. So this, based on this thing, we have the complete networking in the world, and you will, through mobile phone, you are using WhatsApp, right? So WhatsApp, the encryption is called AES kind of encryption, which is the secret key encryption or symmetric key encryption, and there is elliptic curve, which is something related to factorization on RSA type. So all these things, if on classical computer, breaking those are hard. This is proved, mathematically more or less proved, not completely, but more or less proved that these things cannot be broken very easily using classical computers. Now, if you have a quantum computer, the advantage is a small mathematical problem. Let us solve now. Consider I have 3-bit numbers. 3-bit. How many 3-bit numbers are there? How many 3-bit numbers are there? 000, 001, 010, 011. How many? How many? No, 3-bit. 000, 001, 010, how many? 999 for decimal numbers. You are right. So, every location can be filled by 0 or 1. How many options? 2 options, right? Into second location can be put by 2 options. Third location, 2 options. So 2 into 2 into 2 is 8. So, if you have an n-bit number, then there are 2 to the power n such numbers. Now, when n is very large, 100, then 2 to the power n is very, very large. So, writing those 2 to the power 100 numbers is impossible. But using a quantum machine, you can sometimes, with just very little effort, you can generate a superposition of all those numbers, and that can attack such systems. So, that is the science. Let us not get into it in more details. But this is very important, that if a commercial quantum computer comes, all the banks have to change their softwares. So,
Any other questions?
So, if we get quantum computing in the market, what will be its major contribution to the society?
okay, one is we have to, there are a lot of software jobs will be, please sit, a lot of software jobs would be generated. Already we have started writing programs in Qiskit. You can give a search. It is Python-like programming language where people have to start writing programs. Communication would be what I would say, it might be more secure or could be fast through optical fiber cables. So what I would say, it would develop the technology a lot. Okay.
Anyone else?
আমি যদি ছাত্র হতাম আমি বলতাম ওরে বাবা এখনো ছাড়ছে না কেন
Sir, if you can just tell the students about what is the future of research in this field in our country.
Yes, so I think for only science and technology I can really talk. So computer science and technology and related mathematics and AI, ML related to share markets, finance. So those who are interested to gain a career in technological field, I would just suggest you that read very carefully physics, mathematics and chemistry. So during the student life, I did not read physics and chemistry at all. So in deep trouble nowadays in understanding those things. Biology I didn't have after 10, so I cannot tell. But the field of biology is developing a lot with computation. But one thing is very sure, at our childhood, we heard that if you want to do anything in technical field, you have to learn mathematics. And one of the best courses in mathematics is in our institute, Indian Statistical Institute. After 10+2, there is an exam. We have BStat program in ISI Kolkata and BMath program in ISI Bangalore. So I would tell, even if you are not interested in mathematics, if you are studying science, at least write the test. Our test is very unique, very interesting.
Just one question.
You have a question? Yes, please.
Sir, like what does a quantum computer look like? Like, can we ever get it in the market?
Can we ever? I cannot answer, but there are some images that I have seen because China told they have developed one, US, IBM told they have developed one. I didn't have the opportunity to get into the laboratories. So, but it would be some very big machines as we have earlier in 70s or 80s, the classical computers, big Almira kind of thing. And most of the things will be optical techniques, mostly. It is not like in a small box. The chance is very low at this point.
Sir, my question was, this development of quantum computers, when we weigh the advantages and disadvantages, is it more advantageous to society or is it more disadvantageous? Because you stated that once they are developed, then all banks will have to change their softwares, etc. The whole security system will change. So
questions have counter questions. So is the development of nuclear physics good to the society or bad? You decide. I really don't know the answer. The answer would be generated by the people of the world. I don't have the answer.
Thank you, sir.
ওর আরেকটা প্রশ্ন আছে বলো আমি শুনতে পাচ্ছি
I think it depends on how we use it, how the people
Yes, for everything how do we use it?
Yes.
Like a kitchen knife also.
Yeah.
How do you use it? You decide. তাহলে শেষ হয়ে যাক আর কিছু
Just one question, like if we have quantum computer in the future, then what is the future of the classical computer?
Okay, if this is I'm sorry that I didn't talk about this. The future of classical computer will be as it is because all the quantum computational method requires a lot of classical pre-processing and classical post-processing. So this is the very important part that I forgot to tell, that there is no threat to development of classical computer because the input part and output part would surely be the classical computers. In the middle we will have quantum computers. So absolutely, and classical computers are actually quantum computers. It is in the, so it is base and alkali kind of thing, right? So base is the larger class and alkali is the smaller, right? So base is quantum computers, classical computer is a small part of that.
If there are no more questions, then we will close the seminar for today. Thank you, Professor Maitra, for coming to our school and speaking to the students.
Thank you very much for listening to me for 1 hour, right? Thank you very much.